Hi everyone. So today I'm going to give you some tips we gathered in Symfony to get the most out of the PHP engine. So I'm going to give you a few screenshots from Blackfire because that's the tool I've been using to actually measure the improvements and spot them before to prove that some patch was actually doing something. So if you want to give it a try, you should if you don't know Blackfire already. It's a profiler, of course. So Symfony is getting faster and faster at every version. So this is a screenshot from a presentation from Tobias. And he ran Symfony 1 at the time, and then Symfony 2, 3, 4, 5. So that was last year. And as you can see, the time has been improved for the Hello World. So it started at like 200 milliseconds, and now we are at about 10 milliseconds to render the base Hello World. So how did this happen? As you can see also in the table, this happens because we removed code from the hot path. So the best way to take the most out of the PHP engine is to not run any code, right? That's obvious, but that's still something that has a meaning when you're looking at a framework, because the framework adds like things on the hot path, and if we can remove most of the thing, then it's better for performance and for leaving your application, or letting your application able to spend time on its own business. So a few context to put the picture and the talk in the picture and the big picture. So there is the PHP engine, and the PHP engine is quite old, like it's 25 years old. The version 7 has been released 4 years ago, and we just released version 8, as you know, with the just-in-time compilation engine. It's not yet 1 million lines of code, but it's, yeah, almost there. And it has a very unique feature among other engines, like languages. It's that it has a distributed leadership. I think this is a critical thing, and why I love working in PHP. It's that, you know, where Go has Google behind and etc. PHP is really community-driven, and it's proven good to make good decisions, and that try to manage everyone in the community and allow them to move forward while making very good progress. Symfony, on the other side, is the thing that runs, is one of the things that run on PHP. So Symfony is 15 years old now. We released version 5 1 year ago, and we're going to release version 6 in 1 year, because we do a major version every 2 years. As of now, version 5 requires PHP 7.2. It also works with PHP 8, unlike the caret operator suggests there. Symfony is also an organization, so this organization manages 170 packages, about a bit more, and we just crossed the 6 billion downloads when we accumulate all downloads per version and per component. So that's a nice milestone. So it's a bit of vanity information. It doesn't pay any bill, because the download or being a successful open source software doesn't create any revenue at all. But it's still nice to have these indicators of the healthiness of Symfony, the open source project. So the things I'm going to mention are things that I've learned by reading Julien Pauly's blog and Nikita's blog also. You'll find very detailed explanations there about how the PHP engine works. So how does it work actually? So I think you know all about that. And the reason why I'm putting this slide is that we have a challenge. The challenge is to improve the performance of our application. So we have some constraint, and the biggest constraint is the runtime execution model of PHP, the main one. So we have, you know, these requests that don't last very long. So actually in PHP FPM, it's a bit more complex. So when we are using PHP FPM, we have a master process, and the master process manages a pool of separate PHP processes. And within each child PHP process, we run requests sequentially. So one script after the other in all child processes. So it means here one process is going to have a memory reset after dealing with the first request, and then the PHP memory manager will reset memory before being ready for the next request. So this happens sequentially within one single process, and this happens in parallel when we have several children processes at hand, right? So this is something we need to think about. How do we make this fast? Because having like the memory empty for every single new request creates some performance challenges. We have to recreate the world, like the object, the kernel, and things like that for every request. So how do we make these kind of things fast? The first thing is by being lazy, by not doing too much work, and by doing only the actual work that is very needed for this very request. So that's the one trick to make this runtime execution model fast: laziness. In PHP, we have copy and write. So the engine itself has one mechanism that is lazy. It's called copy and write. So copy and write is about not duplicating an array, for example, until the very last moment where the array will be actually modified. So there is some pointer involved into copy and write, and the pointer is, and the copy happens when an array is modified, and only when this happens. So this is quite old, but it's part of the laziness strategies that are possible in PHP and that are implemented in PHP. So this happens for arrays, for strings, most importantly. The second lazy mechanism in PHP is about class loading. So autoloading is a mechanism that is very convenient in our packages to load classes, but it's also very aligned and it fits very well the runtime execution model. It means we load only the code that is actually needed at runtime. Of course, this is unique, kind of unique to PHP, because most other languages are compiled and they load everything at bootstrap, and then they deal with that. But in PHP, the autoloading mechanism is part of this laziness thing. The second strategy to make such a system and such a runtime fast is caching. And there are no other strategies: laziness and caching. And if you can think about a third way, tell me, because to me, this request response runtime execution model has only two strategies to be fast. And caching all the things means not doing the same thing twice when it can be cached. Of course, you know what caching is. So in PHP, there are several places where we can put cached data. And when I mean we, it's the PHP engine, because I'm really talking about the PHP engine for now. So in PHP, there is some shared memory we can use. Actually, there are two places where two memory areas that can be shared. One is the shared memory managed by the operating system. So this one is accessible from all children. And then there is also a memory pool right inside each separate process, so that we can somehow reuse some memory from each child process. And this is where, for example, persistent connections are kept. So a persistent connection is just a handle to a connection network stream that is kept in the process memory in each child. APCU, you know, or OPCache is using shared memory to put bytecodes there. So what else does PHP cache? So PHP cache is the real path. So there is a real path cache that you can use. There is a cache for regular expressions, and there is OPCache, of course. So let's talk a bit about OPCache. So OPCache is a way to cache some steps in the compilation and the execution model of PHP. So as you know, maybe we start with the source code, and the source code is analyzed and turned into an abstract syntax tree. This is a memory representation of the code, of the meaning of the code. Then this AST is compiled into something which is not directly machine code, but is called opcode. And then this opcode table, it's a list of instructions, is sent to a virtual machine for execution, right? So there are a few steps there that are always the same. Given the same source code, the opcodes are always the same. So all these steps, parsing, compiling, they are all put in shared memory, so that on the next request, we can reuse this cache and reuse the cached opcodes. We can do that before actually putting the opcodes in the cache. What PHP does, and PHP 7 improved that, is that it spends a few more time to optimize the code. So if in the source code you have like string concatenation, static string concatenations, then PHP will figure out that this can be turned into a single bigger string, right? And PHP is also able to spot some dead code and to remove some code that is behind falsy, conditional statements. So maybe it doesn't make sense because nobody writes if false. But now, if you think about constants, like if PHP version ID is higher than 7.1, then at compile time, PHP can resolve that and turn that into dead code or no unconditional execution path. There are a few more things that PHP can cache, and those are related to the values. So strings, for example, and also immutable arrays, they can be put in shared memory. And so then when you will use the string and when you will not modify the string in your PHP script, the string will be accessed directly from the shared memory. So in the process, you will get only a pointer to the shared memory area that contains the string. And unless you modify the string, then the string isn't, there is no memcopy happening for these structures like strings and immutable arrays. So an immutable array is an array that contains only static values. I told you about like compile time evaluation. So for constants, so for example, this condition checking the PHP SAPI is something that can be resolved at compile time, so that then your code can check if the version of PHP or something like that. In the code, you can have if condition, but they will be removed at runtime, resolved at runtime. There are some functions, and only a few of them, that allow static compile time resolution. So for example, count is one of them. If you call count on a static array, then the result is known at compilation time. So if there is a constant there instead of this array, which this code doesn't make sense, of course. But then if there is a constant, then this can be resolved at compilation time. There is only one limitation, which is that the function should be fully qualified at compilation time. So usually it means that if you are within a namespace, you need to prefix the function call with a backslash, or you need to declare at the top of the file use function count, so that then PHP can know at compile time which exact count function you are referring to. In terms of inlining, so it's also possible for a few functions to be turned into optimized arrays. So for example, all the type checking related functions are in the list. So if we have this function isArray, if you look on the left side, if we call isArray in a namespace, then you can see the opcodes, this init ns fcall by name, and send var x and do fcall. These three opcodes, they are kind of costly. They are costly because they define a function call. If now you add the backslash in front of the isArray, then the generated opcodes are very much optimized, and PHP at compilation time is able to replace the function call by a dedicated opcode. So there's one which is called type check, and this will just, without doing a function call, a virtual function call, this will return the result much faster. So there is a list that I put at the bottom of the slide, and you'll find it on PHP CS Fixer. There's a list of functions that benefit from this optimization. All the other functions do not benefit from adding the backslash in front because they don't have any corresponding opcode mapping to their behavior. So they are turned into the normal path, and adding the backslash is not faster. Another example here, it's a very simple change, as you can see, and this is a tweet from Stuff, a Symfony contributor. And by just adding one character, this backslash in front of isNull, he saved like almost 3 million calls and 2 seconds in this call graph with just this very change. So it's really fruitful. Just a red slide. Please do not add the backslash in front of all function calls for performance, because that won't improve performance. That will just be noise to the eyes. So there is no benefit in terms of performance in adding this backslash in front of every single function. There is only a benefit for this short list I mentioned just before, and those are the only functions that benefit from the backslash in front of them. Okay, now let's continue. Another thing that is slow in PHP. So PHP 7 is slow at compiling the code. You know, reading the source code in PHP is slower than it used to be in PHP 5. And this is something that happens on Symfony. So Symfony, you know, has this container, dependency injection container, which is a generated class. So the compilation of the container means Symfony generates a big class, a big class. It can be like 2 megabytes or several megabytes of code to define all the services as code. And we did a change a few years ago, not far away, where instead of generating a single big files with many methods, one method per service, we splitted all the methods into separate dedicated files that were loaded then only when needed. And this provided us with a really nice performance improvement. So if you see here, this is a tweet, a screenshot from a tweet. There is someone who reported a page going from 130 milliseconds to 15 milliseconds. So that's a huge win. So maybe you're wondering there is a trick. I'm tricking you. This happens on the command line. On the web, of course, we have FPM, and when we have FPM, we have OP-cache. So the difference is not that high. I'll show you later. But you know, FPM is not the only place where we run PHP code, and on the command line there is no OP-cache because there is no shared memory. And so providing a better experience on the command line is also critical. So that's what is happening thanks to this change now, and thanks to splitting the big container into smaller pieces. It's still faster using FPM. Why is it faster? It's because OP-cache still needs to transfer the list of opcodes, like the compiled class, the big compiled class, is still something that is in shared memory. And when it's going to be needed, PHP is going to transfer the class from the shared memory to the process memory. And this takes some time. It's very optimized because this is a very low-level operation, but it's fast. But it's still something we can measure when we load less code, even cached from OP-cache. Side note here, PHP 7.4 is now able to reference opcodes from the shared memory directly without copying them first. So I didn't measure recently enough to tell you if this makes a difference in this specific case. I think now maybe the difference is not that big in FPM, like 1%. It's not big, but it's still measurable. Okay, another trick. We figured out that by better managing, you know, intern strings and immutable arrays, we could gain some performance. So intern string, I told you those are static strings that are put in shared memory. And same for immutable arrays. They are put in shared memory and they are not copied into the process memory when they are not modified. So this is a change I made in Composer. So in Composer, I opened the source code of Composer with this mindset, with this information in mind. And I figured out that the class map generated by Composer were not optimized, were not static arrays. So if you look at the top of the screen, we are concatenating a variable with a string, and at the bottom of the screen, everything is known at compilation time. So the bottom version is going to stay in shared memory, and the upper version is going to be copied for every single request as soon as we are going to need the class map. So this is, of course, something that is fixed now, and it provided a nice performance improvement in the Composer autoloader. Like, yeah, 11%. And 30%, you know, as you can see here in terms of consumed memory, because, you know, duplicating an array is something that needs memory. So Copy and write is something that works only, when you do not modify an array. So if you take an array, it's static. As soon as you assign anything, any value there, the array is duplicated first and then modified. And this is also the same for strings. So for example, in this code sample, we have the static string, and then on the next line, we create a new variable that holds the same value, so there is no copy. But on the last line, as soon as we modify the b variable, ABC is copied and then in local memory, and then it has the suffix GHAI added there. So if you don't need to actually modify the string, maybe you can use a static string. So here are two examples we found in Symfony to improve the performance. So one is in something that we call compiler passes, but you don't really care about the business. What's strange about this code, if you look at the code, we iterate over an array, and for each value, we process it. So we get the result in a variable which we call processed value. And then we have an if condition. And the if condition is saying if the value after the processing is different than the value before the processing, then we change the value in the array of the same key. We could remove the if, and we could remove this processed value temporary variable, right? We could do it. It would provide you with exactly the same result. There would be a big difference, which would be that we would trigger a memory copy for the array even when the value did not change, because the PHP engine is not able to detect that we are putting a value in this key which is exactly the same as it is before, or it is just before the assignation. So by doing this check explicitly in the code, we gain performance, and we measure performance thanks to this code style. In Composer again, so this is an example from the class loader from Composer. Composer is caching the existing classes, the location of the file of the source code for every class, but it's also caching the missing classes, so that if you try loading a class once, then the second time Composer will know that, no, it doesn't exist, I already checked before. And this information, this cache, used to be stored in the same array where classes are mapped to their files, using false as a value, to have some difference. And by doing this change in this big array, this big class map, Composer was triggering a memory copy. So we were copying, just because of missing classes, we're copying the autoloader class map from the shared memory to the local memory just because of that. So now we have two properties in Composer class loader, one for existing classes, one for missing classes, and this is, providing us with a nice performance and memory boost. What else can be slow in our applications? The autoloader. The autoloader is something that needs time. I told you laziness is nice, but having things preloaded would be even better. So bypassing the autoloader is something that is doable if you are able to do inline require instruction in your code. That's one way to do it, and that's now able in Symfony 3.4, yeah, as written on the slide. We added a way for the generated compiler to add inline require statement for the classes of every service. So if there is a definition for the Twig service, then we know the file where the Twig service, where the Twig class is defined, and we can require, and we can then bypass the autoloader there. So we gain a few percentage, actually a quite significant performance boost in development. And in production, we gain a much less significant improvement, but still 2% is nice. In development, why is it so high? That's because the autoloader we are using in Symfony during development is slow, because it does a lot of checks for deprecation, checking if a class is using some @internal, @final annotations, and many things that are really nice to spot mistakes during development, but they cost a few CPU cycles. And by doing this inline require, we bypass this logic for the services because they were checked before, so we don't need to do the check twice. and this improved the experience a lot when developing with the Symfony. Another thing that can be slow is the garbage collector. So the garbage collector, I'm sure you've heard about it. It's something that is called when you create 10K objects. You can also call it by calling this GC collect cycle function. It can be slow. You don't very precisely control where it's called. So if you have a tight loop that creates a lot of objects, then you might want to disable the garbage collector during the computation of that loop, if you know that it's fine in terms of memory. There is also another part of the garbage collection process, which is not freeing memory unless you call GCMem caches. So this is, for example, the tokenizer, small strings, these things. So don't forget to call that from time to time. And the good news related to the garbage collector is that in PHP 7.3, Dmitry improved this logic. So before 7.3, the garbage collector was triggered as soon as you had like 10K objects. So if you had 10K object, then you went back to 9K and then again above 10K. Then every time you would cross the 10,000 objects limit threshold, that would trigger the garbage collection process. Now what happens is that when you cross the 10K threshold once, it's going to be increased. This test 10K is going to go into higher numbers so that you fit a budget that won't trigger garbage collection much. And that's a very nice improvement. A few more things. So that's very low-level things, maybe not things you should do in your own code unless you spot that this is faster. So this one is easy, and actually it's nicer to read. So if you use the coalescing operator, like this double interrogation mark, you should know that it's faster than using an isset ternary operator, even though it means the same. It's implemented in a more efficient way. So you can use it, of course. There is some documentation on Julien Pauly's blog post that explains why encapped strings should be faster than concatenation. So the left side on this screen, like putting A and B right into the double quoted string, should be faster thanks to a concept that is called ROPTs, and that I don't understand really well, and that more importantly, that I didn't measure ever. So I didn't spot a situation when this made an actual measurable difference. So I'm just sharing that information with you just in case, but there's nothing to remind about that. And another thing is about another improvement in PHP is called packed arrays. So if you manage to have your arrays use only numerical key, like integers, as keys, and if these keys are only in incrementing order, so yeah, the number one after the other in a growing incrementing way, then PHP is able to use less memory to describe and to put these objects in memory. So there are a few cases where you could check and prefer using packed arrays just by taking care of the layout of the keys and these arrays. Okay, and there used to be something slow before PHP 7.3, which was accessing constants. So if you look at this code in Symfony, we figured out that this function, which is the function of the container class, so to get a service, we made the function faster just by not using a constant and putting the raw value there, so 1. So there is the commented constant so that we don't forget why it's 1. But that was quite a surprise. And actually, we reported that to the PHP internal mailing list, and Dmitry again fixed that. So now in 7.3, this should make no difference. So we should be able to remove this inlining that we have in Symfony. I should do the pull request and do some measurement to check that. So if one of you want to do that, please, I would be happy to review your pull request. More things. You know, the casting operators used to trigger copy and write. That's not the case anymore. if you cast an array to an array, it's not going to generate a copy and write. Since 7.2, if you use a switch statement, then PHP is going to use a hash map to jump very quickly to the correct case, if it's possible, like if the switch statement and the case are all integers or strings. PHP will switch very quickly to the correct switch statement, so it's now very fast. About callables, that's something also I measured and that is significant in loops. So if you have a callable, you can describe the callable as, this array, bracket, this, comma, method. And if you call this method a lot of time in a loop, it's better to turn it into a closure before and outside the loop. So to do that, you call closure from callable, and you pass it this structure. You will get a closure object as a result. And calling this closure object is faster than calling this array as a callable. So that's something we use in a few tight loops in Symfony, where we need to call callables very fastly. Something that I learned and was a surprise, someone submitted a pull request on Symfony. If you do a lot of file exist check in your code, you should replace them with isFile or isDir, depending on what you want to check for. But isFile is cached by the real path cache, and file exist is not. And this makes a significant difference in some cases. So in Symfony, we got rid of, I think, most file exist check, and we replaced them by isFile checks. Okay, two more things just to be exhaustive, to give you the full pictures in terms of performance tricks. If you put a method public, and if you put a property public, it's going to be faster to access to. So even though you don't intend a method or property to be used by someone else, putting it public is going to make this piece of code faster. So you can turn everything public and you will gain some percent in your code. I'm not telling you to do it. I'm just giving you the hint in terms of performance. There are some situations where maybe you'd be happy to reclaim the small improvement in terms of performance that could provide. And another way to gain some performance is by removing type hints. You know that PHP is a runtime checked language and engine. So when you add the type information on a return type or on an argument type or on a property, it means you are asking the PHP engine to do some more work when accessing or calling this function, etc. And you can give it a try. If you remove the type hints from those methods, you will measure something in terms of performance. So again, I'm not telling you to do it. I'm giving you the hint that in some internal code, maybe you could use these tricks to gain a few more CPU cycles for doing your job. In PHP 7.4, we have something that I'm sure you've heard about, which is called preloading. So preloading is I think, pretty new for the community, new in terms of adoption. I don't know how many of us are using preloading in production. There are some challenges to using preloading. So I'm going to list them here in two slides. So what is preloading? Preloading is about putting classes in shared memory as OP-cache statements, right? But preloading is also about resolving inheritance at compilation time. So basically at preloading time is more accurate. Because without preloading and with classical autoloading, PHP has a job which I didn't know about really before reading about preloading. But PHP stores OP-cache opcodes independently for every single source code file. This means that when a class extends another class or implements another interface, PHP at runtime has to check if the parent interface is correctly implemented in the child classes, right? So this is some logic that happens at autoloading time, and that preloading is aimed at completely removing. So preloading removes these steps, and it also removes all the freshness checks that OPCache does to hot reload the code when it detects that the file system updated the source code. So all these are gone. Now, when you enable preloading, PHP is going to consider that the source code is completely static. It's going to load all the code in memory. It's going to resolve as much as it can, inheritance included, and it's going to never check again the source. It's going to use memory only to give you the code from shared memory without copying anything in the process memory. So it's kind of nice in theory. Let's see in practice how this works. In practice, it works with a hash map. I mean, there is some hash map that has as a key the class and as a value the opcodes in shared memory to know where they are. And a hash map is sensitive to collisions. So if you put too many things in a hash map, it's going to slow down the hash map. What I mean here is that you will find some comments from Dmitry on GitHub where he states that if you load all the code in the vendor directory, even the classes that you are not going to use, but they are still there in the vendor directory because there are many classes you don't use there. So if you over preload, if you load all classes, then your application might be actually slower when using preloading. So you should load less classes than all classes available in the vendor and the source directory. And on the other side, preloading has an issue with under preloading. So under preloading is when you load nothing. When you preload nothing, of course, you are under preloading. So when you load 10 classes, maybe you're not loading enough classes. When you load 100 classes, maybe it's not enough because your application is commonly using 1,000 classes. So that's what I call over preloading and under preloading. And basically, this tells us that there is a challenge in preloading, which is identifying the set of files that are useful to preload. And that's not all of them and not, too few of them. So that's the challenge. And this challenge requires an implementation. So it requires some logic we have to implement. And we have to implement a preloading script. And the preloading script is this logic that knows which classes from vendor and from source folder which classes should be preloaded. This is quite challenging to do. It's challenging because it depends on the configuration of your applications. Composer is not the right place to know. Composer doesn't know anything about where you are using the vendor directory. So only the application knows which classes should be preloaded. So in Symfony, we added some logic, and there is a preloading script that is created by Symfony and that looks at the service definition. So by looking at what the container contains, Symfony is able to deduce, to infer which classes are going to be actually used in the application. And so that's how we generate a preloading script that is kind of good at not doing under preloading and not doing over preloading. I'm sure you can fine tune and you could spend more time into selecting very precisely which classes you want to precisely include or preload or not preload. I think this would require a lot of work. So yeah, do it if you want to spend and if there is a benefit, and don't do it and just use the Symfony script. Most of the time, I think it's good enough to skip the preloading step and the autoloading step. So congratulations to Dmitry and Nikita, because those are the two people that worked on preloading, and that's quite a nice achievement. To do preloading, there are two strategies. One of them is calling include and using the autoloading at preloading time. And this has the benefit that it will run into the conditions in your code. So if your code is conditionally loading a class by checking the version of PHP, etc., this will work. There's another strategy which is using OPCache compile file. And this one just opens a file without executing the content and loads everything it can find there. I would recommend you to not use this strategy because, as I told you, it's not compatible with conditional loading, and so it's less flexible. I told you about the preload.php file that is generated in the config folder by Symfony. So it generates things out of the container, but it generates things also out of cache warmers. So I'm thinking about Twig templates. You know that Twig is compiled into PHP, and then those are classes, and we preload. Symfony is able to preload the compiled Twig templates, and same for the translations and etc. So as a result, on a Hello World application with Twig, I measured like 55% improvement. Of course, this application does nothing but use the framework. So we reduced a lot the overhead of the framework itself, and really a lot. So the application does nothing. And on a typical application, what I see when we use autoloading, when I use autoloading, is that when I use preloading, is that the autoloading, everything related to the autoloader is kind of removed. And if you are used to looking at profiles of PHP application, autoloading is consuming 15 to 20% of the runtime execution on a typical page. So that's something that you gain by enabling preloading. So yeah, just do it. It works, and it should be pretty stable. This requires a few hints. So this is a hint we added in Symfony. So this is one class, and right inside the constructor, we always use a few extra classes. So preloading works by looking at the parent classes. So resolving the inheritance tree, and all the classes in an inheritance tree are kind of things to preload. But there are more classes to preload that we cannot spot using basic static analysis. And to hint the preloading script and the PHP engine that a few more classes should be preloaded also, we added, and you'll see in Symfony, this class exists entry before class declarations. They are there to help the preloading script preload this class. By just checking if they exist, they will be loaded, and then the preloading script and PHP will put that in shared memory so that they will be available right away when you'll use Symfony without any autoloading for them. Okay, so short conclusion, and I'm done. So PHP 7 is really a rock star. It improved a lot of things. Let's see now what PHP 8 is going to provide us with just in time. Look at the source code. I open the source code of PHP quite periodically to check how it behaves. I mean, writing C is, I don't know, I'm not able to write C, but you know, reading C is kind of possible, at least from afar. So it gives hints, and useful hints, because that's the truth. Do not do tight optimization or like performance optimization outside of tight loops. It doesn't improve anything. So just do this kind of specific optimization in loops that are, you know, running a millionth time, because that's where it's going to be really useful. Then a micro optimization is not going to be micro anymore. And there's only one way to actually prove that some piece of change or some code is faster. It's by measuring it. So never stop measuring. You can have some intuition about some piece of code saying, oh, this is going to be faster, and measuring can prove you wrong. And then that's done. If there is a decision to make about some piece of code, you measure and you decide if it's good or not in terms of performance. Thank you very much for listening. Thank you for inviting me to the conference. I hope you enjoyed the talk, that you learned a few things. I don't know if we have time for questions or if questions are possible, but yeah, enjoy the conference.